Hey, big brother. Got all the pill strips cut. Got your hot bus done. I was gonna go with a solid copper, but I think I done decided what I'm gonna do. Actually, is come up here with three 8-gauge wires evenly across here, which will be way more than efficient. And haven't quite made up my mind yet if I'm actually going to come from up under right here or not. That's something still I got to make my mind up about. I got to figure out where I'm going to put the thermal cutoff and all that good stuff. But as you know, this is going to be an AB biased amplifier. I want this heat to be dissipated equally across both of these heat sinks. These are some heavy duty heat sinks. Got all your transformers already wounded up, man. Every single one of these transformers are matched, which means I probably went through about 1, 2, 3, 4, 5, let's see, maybe 15 transformers. So I sat there and wrapped about 15 transformers and basically got the 4 output and the 4 input that matched closest together in inductance. I mean, I'm going all out for you, brother, like I told you I would. Every capacitor is going to be matched. Every aspect of this amplifier, even the chokes right here, man. I already had about 20, maybe 25 of these chokes right here already wounded up. And give a major shout out to Mr. Stickman. He'll know when he sees this. But it's gonna be kind of a twist design on how he does things. I already talked to him about it, actually. He can't wait to see it. But anyway, these are matched as well, man. Even the dang splitters and combiners. So I'm going on out like I told you I would, bud. We're about to get the transistors in here. I'm gonna go through here and tap all these holes and use Allens like I usually do. I like to use them Allens, man, because I can really get them torqued down. If I can find me some Allen screws that are self-tapping, which I have searched absolutely everywhere. I cannot believe there's no 4-40 self-threading socket machine screws. Anybody that can locate those for me, I'll give you a $100 bill. Yes, you heard me right. Anybody that can locate those for me, I will give you a $100 bill sent to your PayPal, check, money order, doesn't matter, cash, because I have looked everywhere, and that would save me a lot of time. I wouldn't have to sit here and manually thread all these holes. But alright, man, let's go ahead and get on through it, man. Get these 8 non-dot Japanese soldiers put in this cotton picker, man. Get this thing built. Boy, this thing's pretty, man. It's gonna be pretty. Alright, we'll see you. Bye-bye. Alright, brother, this thing's coming along real nice. Got the transformers down, transistors, got the metal 120s, the 10 ohms. And about to put the feedbacks on there and the filter caps on the hot bus. And on and on we go. I'm hoping to get started on your 6 pill here next week. And maybe your 5 pill too. We'll have to wait and see how everything goes, man. Alright, buddy, just want to do a little quick video showing you the progress here. This thing's going to turn out nice, man. The old gatekeeper said it. We'll be back in a bit, or at least it'll seem like a bit to you watching the video. Alright, big brother, I'm about to go hit the sack. I think this is a pretty good stopping point right here, man. That's what I like to call the heart. Alright, everything's looking good and everything's coming together good. We'll be back. Wow, I think my flash is working now. Alright, big brother, well here she is. I know you've been waiting a long time on her. Here we have a straight 8, all Toshiba, all metal clad, 8 transistor amplifier, AB biased, regulated AB. And this thing does have some pretty cool features that was requested. Basically, it's got a thermal protection circuit, and that's what this switch right here is for. Okay, you can turn it on or off. Basically, if it's turned on and you have an ambient air of about 115 degrees, it's actually coming out of the heat sink, not on the heat sink, but out of it. You will see this LED light up right here, okay, and then the relay and the bias voltage will be disengaged until, you know, it cools down and the thermal switch turns off. So you got some thermal protection there, which you requested, and this puppy here's got what, 1, 2, 3, 4 relays in it. And basically this right here is your bias relay right here. This right here is for your thermal protection circuit, so when it's turned off it's bypassed. And this little neat relay right here is, which I will be showing here in a little bit. I still need to hook the fans up, but I thought I'd go ahead and start the video now. Well, them fans are, they look beautiful when they're on too, man. Got you screen protectors like you asked for. Let me turn this flash off, but it looks good. It looks good. So basically, this amplifier here is not designed to be a big mall box. This is designed to be a linear amplifier, smooth amplifier. You're not going to see them big monster watts like you would out of a Class C box, you know, or whatever. It's not really designed to be an amp like that. So basically, my my buddy here wanted a variable fan controller to be able to control the speed of his fans. Well, since he had been waiting a good little while for this, by the way, this is a 100% House of Color candy painted box, inside and out, which is hard to get my painter to do that because these are not powder coated boxes. These boxes are painted in a professional paint booth, okay, and a real deal paint booth that can hold about 2 vehicles. And he, you know, when he paints them, he has to make sure there's no vehicles in the paint booth. It's got to be scheduled and all that good stuff. And it's just not the easiest thing in the world to paint the inside and the outside of these cases. As you can see, the top is done that way too. Because when you're doing the candy paint, you have to do quite a few coats of clear. And I mean, you're talking about, you got to know what you're doing to keep that clear from running. When you know, basically you have to paint the outside like what he had to do. That's why it's kind of hard to see on camera, but the outside is a different color blue than the inside. But basically you have to paint the outside, then tape up the outside once it's cured, dried, the whole shebang, and then do this. So it's like painting two separate boxes in a sense. So yeah. But anyway, since he had to wait a little extra time than anticipated, I thought I'd do something special for them. I went all out and gave him a touchscreen variable fan controller. And this bad boy plugs in right there in the back, as you can see right there. Right above the negative connector. Okay. And after I do the output test and everything, I'll hook this bad boy up. I might have to move that driver to set this down on it. But it was a little learning curve to get this fan controller working, because I fried the first one. And I'll get into some detail about that later. But basically, them fan controllers are designed for computers. So basically, I learned pretty quick I had to simulate a computer power supply inside that box. So, alright, so we're going to be doing something a little different than normal. Okay, I do not even want to turn this amp on or run it on my unregulated power supply. Okay, because there's some sensitive voltage devices on this amplifier. In this amplifier, we got the temp sensors up under this board. This took some designing, some planning, because as you can see, just by looking at this at first glance, this looks like a regular Class C choke soldered to the board right here. Well, as you can look a little bit closer, that's not. That's a wire going in. It's a wire actually going in up underneath. Whenever you're running wire through heat sinks, you have to be very, very, very careful. Use a lot of extra protection. So I had to buy some 2 or 3 different size Teflon tubing to run these wires through, so there will never ever be a chance of these wires being chafed against the heat sink, anything like that. Yes, this is Teflon, but you want to double and triple, use triple safety when running wires through anything that's going to be getting hot. So this bad boy is wired through the Teflon wire, high temperature heat shrink, then through the Teflon tubing, and they all go back here to the bias circuit. Okay, and you can see one sandbar is for this 4 transistor section, the other one's for this 4 transistor section. Get a better view of it right there. It's just your basic old school design regulated circuit. And so it took some planning, you know, just to make sure all them wires are ran as safe as absolute possible. You got to think about shipping, etc., etc. So basically, I'm going to do something I hadn't done in a while. We're going to be just testing this on my battery bank over here, with all that stuff sitting on top of. None of that stuff's conductive, and I ain't going to have nothing blowing up on me today. I've got 1, 2, 3, 4, 5. Well, let's see. 1, 2, 1, 2, 3. There's 4 batteries that are actually hooked up over there. So we're just going to be doing a test. So you're not going to see the maximum power that you would see, you know, on a good power supply. All right. Just want to show you that it's working. I still have not got me a real good regulated supply yet. I need about 1,000 amp regulated supply. I'm working on it. So if I did have one, I wouldn't have to resort and hooking this sensitive beast up on the batteries. But you know, it'd be enough to show you that it's working. It's working good. So we got the 4-watt radio as usual hooked up. We should be seeing about 600 bird with this radio. Okay. It's going to be dropping to about 11 volts or so. I've got the 1446 2-pill, the AB bias 1446 2-pill. It's going to be throwing about 100 bird into the 8-pill. Okay. Alright. Make sure I got everything hooked up right here. Just for rock and roll. Alright, that's just the 2-pill driver there. Oh, right there about 100 bird. Oh, flip the 8-pill on now. Right there about 600 bird, just like I thought. Alrighty. Of course, that's going to be off the scale on peak. 1,000 watts. Oh, in the corner. Even on batteries, fellas. It is quite embarrassing. You think old Gatekeeper would have took the time to build himself a good, strong, regulated power supply, but I have been working endless amount of hours for about almost a year now on getting caught up on all these extra builds, including this one right here that I took on and really shouldn't have. I got a little bit too excited and took on way too much work, and I am literally right there about to caught up, right there at it. And I have literally had no extra time to do any kind of projects for myself, build me a power supply, etc. So I've just been kind of using what I've had to get, to get by till I am caught up, so I can start doing stuff like that. And we are literally right there, right there. It's been a long time coming. We got the diode protection in there because you got to think there's two different wires going to this fan. That's something else I'm going to explain later on. But basically, if the fan controller is plugged in, there's a self-activation inside the box. It basically activates this relay right here, okay, that then redirects the DC to the fan controller, out the fan controller, up to the fans right here, okay. So we got two different connections here, right here at the fans, and I've got these diodes here, so there's no back feeding going into the controller when the controller's off. So right now, and basically I had to do that because I didn't want it to where you had to run the fan controller. If you did not want the fan controller, then the DC needs to be bypassed and straight to the fans, okay? And the way this is all set up, I could not do no protection on the fans, no voltage protection on the fans, or it would mess up with the fan controller. And I'm about to run out of time here. Let me press pause so we can get a quick look at the peak watts, and I think I'm going to have to free up some space before I continue this video. I'll be right back. I went ahead and hooked up the old hot radio here, so we're going to be putting about 8 watts RMS into the 2-pill driver, and I'm surprised it's doing this much on batteries. A 1,000 watt slug. Oh, look at that right there, 1,000 bird. Oh, 1,000 bird. Alright, let me press pause real quick and put my 2,500 watt slug in. Alright, real quick. Almost getting close to 1,500 watts. I'm surprised it did that amount of bird on those batteries. So if I could get this. Alrighty, I'll go ahead and demonstrate the fan controller, which I have not had time to sit down and really get acquainted with it yet and learn it. I'm going to send the instruction manual, of course, and let you learn it, set it up the way you want. It's a pretty high quality Lamptron CM430, and like I said, these are designed for computers primarily. So it took a bit of a learning curve, and I had to blow one of them. It's just the luck sometimes of doing this type of stuff, man, when you're doing custom stuff you've never done before. You know, sometimes you have a little learning curve. But basically in the instructions for these fan controllers, they do not share with you that the controller itself has circuitry on the board that runs on a 5-volt source as well as a 12-volt source. They don't share that with you. So I had to learn that the hard way and blow one. And so it cost about $111 to get another one sent out here first day to me from the beautiful company of PCS. But I got one sent out here to me, and basically what I had to do was simulate a computer power supply. So inside the enclosure here we have a 5-volt regulating source and a 12-volt regulating source. Okay, so basically when the fan controller is plugged into the back, there will be a self-activation. There's a self-activation circuit built inside the enclosure for the fan controller that engages the relay inside the amplifier to divert the DC through. This is very high quality shielded wire right here. I want to make sure to use shielded wire since this is going to be connected to a source that's generating RF. Some very high quality Allen Bradley type 6 conductor wire, I believe it is. Give a shout out to my buddy Mr. RF Man for hooking me up with this wire right here. Very good wire, shielded to the brim. and so the cool thing about it is when you unplug from the back, when you unscrew and unplug from the back, the relay will be disengaged and the fans will be running directly off your power source. Now please keep in mind, this box does need to be ran on a regulated supply if you can help it. Okay, if you're running this fan controller, this has to be ran on a regulated supply. It really does need to be. Okay, when you unplug this fan controller, there is no regulators, there is no resistors at all protecting these fans. I kind of had to do it that way because if I had resistors, etc., on the fans, then you would not be able to use the functions of the fan controller because they would be set at 1 voltage only. But so I would try not to run these fans any higher than about 14.5 volts if you can help it when you have the fan controller unhooked. I have never really took one of these fans to the maximum voltage to see what they can handle, but they're Yate Loon fans which are no longer made. I'm pretty much buying from my source I've been buying from until they're out, and then I'm gonna have to find another fan to use on everybody when anybody wants an LED fan, because these are the fastest LED fans I've been able to find, bar none. Alright, so let's go ahead and show this. Now after I get done I will show it with it unplugged. So the amp is on. Okay, the amp is on right now. I'm gonna go ahead and just touch the controller, turn the controller on. Just give it a second to boot up. Oh, never mind. Okay, now I'm gonna turn it on. There we go. And there we go. Now the only thing that I do kind of hate that I did, it's just a habit whenever I get a fan, is I always remove the yellow wire. The yellow wire on these fans, because we're using computer, these fans are primarily designed for computers. You know, all the fans we all use pretty much. And they have a yellow wire which basically allows the BIOS to know exactly how many RPMs the fans are spinning. Well, I had bought like I think around 100 of these fans at one point, and I went ahead and went through all of them and got them all prepared with ferrite beads and removed the middle the yellow wire, so because we don't need that wire, it's just in the way. But I kind of wish I would have not done that. Now it ain't that big of a deal, it just won't show you your RPMs, because you don't have that wire hooked up like right here. See, well, right there, RPM, which ain't a big deal. It's just showing you how fast it's spinning, but it'd been kind of neat just to see the RPMs of it. So like I said, I haven't got to sit down and really get acquainted with this fan controller yet. You can do a lot of cool stuff, like basically you can put it on automatic mode, which is right here at the top. You switch from automatic to manual like that. And the plastic cover is still on here. I'm going to leave that on there and let you take it off when you get it. But basically you can set different temperature ranges. Like you can set a high temperature. Basically if it gets to a certain temperature, the fans will increase. You can set it at a low. Once it gets to a certain temperature, it will slow down. You can do a lot of cool stuff with it. You can also check some reviews on eBay, YouTube, excuse me, on YouTube if you want to see, learn how to use it. But this does have up to 4 output ports on it. As you see, this 1, 2, 3, 4. We've got these 4 fans hooked up to 1 port. They can handle about 2.5 to 3 amps a port. And the if I wouldn't have done that, it would have been crazy, man. If I would have done, like, put each fan on its own port, we would have had, you know, 8 wires having to come through here. I wasn't out trying to do all that crazy stuff, you know. I was just going to kind of hook up a... I came up with this idea afterward. I did not charge him any extra for this, even though it's cost me about that. My phone got below a certain percentage of battery and it always shuts off. I need to turn that off. But anyway, it ended up costing me about $200 in total because I fried that one. Had to get another one shipped out here first day. And I mean, it was here literally the next day before 12 o'clock. I think I ordered like at 2 o'clock, 2:30. It was here before 12 the next day because I needed to get it in here and get it done and get this out to him. He's been waiting for a while. So it's just the name of the game, man. You know, I'm not the best when it comes to cutting stuff, making it look the best. I've never been at the absolute best at that, but I did my best, and I think it turned out pretty good. And just to show you that I ain't lying, I had to chop up this computer right here, an old E-machine I had laying around, just to get the mounting bracket. So I could actually mount that bad boy. And they mount in a bracket similar to this, which is a 5 1/4 bay of a computer. It's pretty much similar to that. So I went ahead and got 2 of them. I got this one right here, so if anybody sees this and wants something in the future, wants one of these in the future, I got another one right there I can use in the future. But here it goes, man. I'm gonna leave it to you and let you learn how to use it, which I have not had time to do, like I mentioned. And there is a temperature sensor. Like I said, we've got I think this is a 5. Yeah, I got a 5 wires. There's 5 wires coming from here to here. I think I already explained that in one of the other prior clips. But one of those wires is to a temperature sensor, which is mounted right there at the heat sink, and it's measuring the ambient air. So this lets you know right here the ambient air is 74 degrees Fahrenheit. It's coming out the amplifier. So you'll be able to sit here and see how hot the amplifier is getting. And like I said, this is not showing the heat sink temperature. Okay, this is showing the ambient air leaving out of the back of the box. So it's going to give you that reading. It would be kind of cool to see both readings just to see, but that's what this is going to be running off of, the actual exhaust coming out of the back of the amplifier. So you can run off that. Alright, man. So let's go ahead and turn this off. Actually, I'll just turn the box off. And I'm going to come back here and unplug it. I went ahead and made you a ground wire to send with you. You may want to use it, or you may want to make you another one. a 4-gauge ground wire right here and put a ring terminal on there for you, a lug. So since I've unplugged this now when I turn this on, it's going to be ran just like this circuit wasn't even thought of. So now when I turn this on, it's going to be running directly off the power supply's voltage. And as you can see, before it was running on about 11.8 volts, I believe, with the fan controller. And of course, you can get in the fan controller and turn it down from there and go down to, you know, 7 volts. I think you possibly even go, let's see, I think you can go all the way from 0 to 12 volts with the boost setting off. So you can do some neat stuff. Me personally, the fans are not really loud, you know, so you may just want to use this just to monitor your heat and stuff. Maybe have a temperature alarm set on. And the cool thing about it, when that temperature gets to that certain temp, their alarm will actually go off inside here, and you'll hear it go off. You're like, oh God, the box is getting a little hot, or it's getting at the temperature I set it at, you know. So that's kind of cool technology. It'd been kind of cool to have this, you know, mounted in the box. Now that would have been really neat, wouldn't it? But you know, it was something that was thought of later on, you know, so I went ahead and just made it an external accessory. So here we go. Let's see, the power supply voltage is on. I got the box hooked up to this power supply right now. It's at 14.5 volts. Okay, so you can see they're a little louder, pushing a little bit more air since they're on 14 volts or so. So there she goes, man. And I do dedicate this build right here to my buddy Mr. Stickman. Rest in peace. God bless his soul. He was a good mentor to me when I got into this hobby. The very first amp I ever sent out to get repaired that I built, which was the 2-pill, was sent to Mr. Stickman. And he fixed it for me, told me what I'd done wrong. Without him, I wouldn't be where I'm at now. And the design that this 8-pill is built upon is a design that he showed me, which is a great design for sideband users. I've now kind of moved on to a different style 8-pill transistor design that does a lot better for AM users to me, but I'm always going to use his designs at times that he shared with me with specific situations. Now the 6 transistor design that he showed me, I'm always going to use that. It works great, absolutely great. So I want to dedicate this amplifier to Mr. Stickman. Okay, Mr. Chris Myers, God bless his soul. This amp is dedicated to you, my friend. 73s to everybody. Thanks for your patience. We're moving on right along the log, and we're about to be caught up finally. It has been a long time coming. When I get caught up to the right point, then I will start taking more in. We're good and gone. 73s. Bye.